Yeah, BGP authentication, it supports only MD5 authentication. You see, we got authentication when we logged into your PC, when we log into a bank account. Why there is need for an authentication for a routing protocol? In fact, the authentication for routing protocol is more important than your bank account authentication. Why? Because BGP is a protocol that is connecting the entire world. So if one bad guy runs his BGP and give wrong route information, it is not only affecting the next autonomous system, it's going to affect the entire world. So such a routing protocol must have a very secured authentication. Authenticating itself is secured, but it needs to be more secure. That's why BGP don't support clear text authentication, only MD5. Only MD5 authentication. BGP authentication is MD5. And configuring it is very easy. You need to say to which neighbor you are enabling the authentication. From which neighbor you are expecting the password. The password is a pre-shared key. You put the same password on either side and they share, they form neighbor. It's going to be ciphertext because it's MD5, message register. Right, so router generates and checks MD5 digest of every segment sent to TCP connection on TCP connection. Every single BGP conversation needs to get authenticated because BGP uses only TCP. Router authenticates the source of each routing update packet that is received. See, configuration. On both the router, we put the same password. We no need to put this type of alphanumeric as a password. If you want, you can do it. This is going to be hashed again by MD5 algorithm. Very simple authentication. Neighbor's address, password. Some show commands. If neighbors are fully established and when you learn routes, you should see the routes by typing show IPBGP. We'll be learning about these things in next chapter. Metric, local preference, weight, path, what this origin code means, what this RIB failure means. We'll learn about all these things in coming slide. We call these as attributes. Okay, RIB failure, you see, R. RIB failure. RIB means routing information base. Routing information base. Routing information base failure. In another word, routing table is rejecting BGP's update. That's the meaning of RIB failure. I repeat again. The routing table is rejecting the BGP's recommendation, BGP's route selection. BGP is selecting a route saying, hey, this is the best route for this destination. But your routing table is not ready to accept it. Tell me, when will routing table reject? When will routing table deny a protocol's route. When will routing table
If
reject a routing protocol's recommendation?
if it find another routing protocol that have a best path, like a shortest path, or maybe a static route to the path,
You're
something like
almost
that. Something
close.
it just finds something. It find a different route via maybe another IGP
When it finds the same network with better administrative distance, isn't it?
distance. Yes.
When the administrative distance of other routing protocol is lower, routing table will ignore this. Yeah, see for IBGP, what is the administrative distance?
20.
Uh-huh.
No,
Then
no, 200. For IBGP, 200.
very well said. So this 200 is bigger than any other routing protocol. Administrative distance is too big. Too big is bad.
Right. Right.
So what happens is, even though it is BGP, if OSPF provides the same network info, BGP route will be rejected. Those routes are called as rib failure routes. So in your screen here, what you see, the two networks, three networks that you got are, actually it is only one network with three paths. This one network. What does it say? It says that we got someone providing the same network information, same destination route with better administrative distance. So BGP, according to BGP, this is valid at best. But according to the routing table, it's not best. See, read this line. What does it say? Displays network that are not installed into the
It's
routing table, and the reason that is where that they have they were not installed is
higher administrative distance.
correct. Administrative distance of BGP is higher. For that reason, the routing table is not ready to accept this for these two networks. 172.31.1 provided by 172.31.1.3. You see, 172.31.1 network and 11 network. Okay, now there are route refresh options available. If you want to refresh route in OSPF, we used to type clear IP OSPF process. Do you remember?
Yes.
But is it a hard reset or a soft reset? It's a hard
Hard
reset.
reset.
But in BGP, you got a good news. You can do soft reset also. In order to refresh the route, you can use either hard reset or soft reset.
Soft reset.
Hard reset is simply like this. Clear IP BGP all or clear IP BGP, you can say on particular neighbor. It's up to you. You can say one particular neighbor or you can say all. This is hard reset. When you do this, what really happens is the neighbor is getting discarded. The neighbor will get discarded and it will get re-established. The neighbor will go down and come up. It's a disruptive one. Hard reset is disruptive one. So we do what? Soft reset. Clear IP BGP star means to all the BGP neighbor, the information will be sent once again. So this is a highly recommended option because it is not a disruptive one. For example, when we do the attribute lab, I'll be using this command repeatedly. in order to send the latest changes that I have done to the network. Whenever you do some changes to the attribute, it is always good to refresh so that the latest one, the changes that you made will get applied. Otherwise, you need to wait for some time to get applied. All right, you can say hard reset or soft reset, soft in and soft out, only sending out. This is only receiving. Soft reconfiguration inbound. This router stores all the update from this neighbor in case of inbound policy change. This is memory intensive. What is this meaning? It means that it will maintain a history so that you can roll back. That is why to maintain history, it needs memory. Whenever you do some changes, the changes get stored. And when you do another change, the previous change that was there gets stored to a memory location so that you can reset back, you can go back. Soft in, soft out. Okay, there are some debug commands, debug IPBGP update. See, after typing debug IPBGP update, you are doing a hard reset. When you do hard reset, what will happen? The neighbor will completely go down and then neighbor will come up. When neighbor comes up, see, here it says some output omitted. What is that output? Neighbor going down and coming up, those outputs are omitted. When you clear, the neighbor will definitely go down. And then you will see neighbor coming up. As soon as it comes up, you will see updates sent with some next stop behavior, means next stop updates. See update packet, received update packet, send update packet. So this chapter was teaching us a lot of basic information about BGP. We really learned a lot in this chapter. Too much. Starting from how to configure BGP down to the eBGP multi-hop, update source loopback 0 or update source and interface name, eBGP multi-hop or TTL security, and then next up behavior, best entry point, peer group, and then how to use network command if the network that you are advertising is not a class full, then you need to mention the mask to match the subnet on the interface. Use the keyword mask and then type the mask. Synchronization rule is not necessary, but just for knowing, we learned that synchronization rule states that you should not use or advertise the route learned from an IBGP to eBGP. You should not give to any eBGP until an IGP routing protocol matches with the same route. It's off by default, so you don't need to worry. It is good that it is off. Otherwise, all the BGP network is expected to be seen in OSPF. Only then it will get advertised. Then we learn BGP states: idle state, connect state, open sent, open confirm, and established. When it is trying to find the best route to reach the neighbor, it will be in idle state. After finding the route, it sends the connection establishment three-way handshake packets. Once that is done, it goes to open send state, where the very first BGP packet with the router ID goes to the neighbor. And when the neighbor receives the packet, if neighbor is also ready to form neighborship, it goes to establish. If not, it will go back to actively looking into neighbor. It will go to active state. When all we will have active state, whenever the neighbor address is wrong, whenever the neighbor autonomous system is wrong, whenever there is no IP path, you will get active state. Active means what? It needs to start from the beginning to establish neighborship. You can also use IPBGP, show IPBGP neighbor command to see whether neighbor is established or not. You see the third line red color, BGP state established, but not really recommended because it will have pages of information for each neighbor. If you want to
Right.
see all the neighbor in one page, better type show IPBGP summary. Show IPBGP summary. It's about active state when all the active state will be there. Whenever we have some misconfiguration of IP address or autonomous system number or unreachable source, fine. So whenever you have this FFFFFF, you need to be checking two things. One is autonomous system number may be wrong. The second one is the neighbor IP address may be wrong. Show IPBGP summary shows all the neighbor in one small table. To enable authentication mode, authentication, MD5 authentication, we need to go under BGP mode and say neighbor followed by neighbor address and then the password. BGP supports only MD5 authentication, so passwords are sent ciphertext. Like this is how we configure. Show IPBGP shows you the destinations that you learned as well as advertise. So if you're advertising any network, the next stop will be 0000. So in our case, 10110 and 10101, both networks are locally advertised as well as learned from the neighbor. We learned about RIP failure. RIP failure occurs only when there is another routing protocol with the same route whose administrative distance is lower than BGP. It's not a serious issue. It simply says that unfortunately I'm unable to use the BGP or IBGP given update because of other routing protocol. According to the routing table, the one with the lower administrative distance should be utilized. At last, we learned about the reset or refresh of BGP. You can do hard reset by typing clear IP BGP star. Soft reset, you need to type show IP clear IP BGP soft out or soft in. And debug command for BGP debug IP BGP updates. So when you refresh BGP by typing clear IP BGP neighbor address, you will start seeing the neighbor getting re-established and all the updates are sent once again to the neighbor. Right, so that's about this chapter.